Hello, and welcome to Math with Mr. Bill. I'm Bill Anderson, and today we are working through a series of problems to help one of my students get ready for his final. These problems come from his midterms. This problem comes from his second midterm. It's problem number 3. We're asked to find the orthogonal families for the curve y squared equals k over x. Now, this particular relation describes a whole bunch of curves depending on what k is. And with these curves, we can find the slopes of the curve at any particular point. Now, to be orthogonal means that you are perpendicular to something. So what we are looking for is the family of curves that are perpendicular to this curve at every single point. Sounds harder than it is. It turns out to be a fairly easy problem to work through. So we're going to do this by steps, since it's going to end up being an algorithm to get through this problem. The first step is to solve for k. So number 1, solve for k. A real easy step here for this one. We're just going to move that x up. So we get x times y squared is equal to k. The next step, we're going to find the derivative with respect to x. We're going to find dy dx or find y prime. And because this is a relation, we're going to have to use the product rule and implicit differentiation. So I'm going to assume that you're familiar with the product rule. And we're going to take the derivative of the first one first. So the derivative of the first, which is 1, times the second, plus the first times the derivative of the second, in which we're going to have to use the implicit differentiation because y is a function of x. So I get 2y times dy dx. And then that's all equal to the derivative of k. And since k is a constant, that's just going to be 0. Okay, so the next step is to solve this for dy dx. And we'll move that y squared over. So we get 2yx equals, 2yx times dy dx is equal to negative y squared. And then we'll go ahead and divide both sides by 2yx. So we get dy dx is equal to negative y squared over 2yx. And then the y's will reduce, and we end up with negative y over 2x. Okay. Get that written down. Okay, so this is the equation of our slope of that curve, of the slope of the curve at any particular point. We want to find the curve that has the perpendicular slope to this. And to be a perpendicular slope, remember from algebra 1, to be perpendicular, that means the slope has to be the opposite reciprocal. So the curves with, or we can say the curves that are orthogonal. So the curves orthogonal to this, if I could spell orthogonal, have opposite reciprocal slopes. So our new curve, so the orthogonal curves, so we're going to switch to that. The orthogonal curves have a slope dy dx equals, and we're going to flip it and change the sign, 2x over y, positive. Okay. Cool. So now all we have to do is figure out what curve would give us this derivative. And we just have to work backwards. This happens to be a differential equation, a separable differential equation. So we can multiply both sides by y and get y times dy. And multiply both sides by dx, which gives us 2x dx. And now we're going to integrate both sides, solve this separable differential equation. So we get the integral of y dy is equal to the integral of 2x dx. And we get 1/2 y squared is equal to x squared plus c. Or k if you want, keep it with the same notation as we had before. And then we solve this for k. So 1/2 y squared minus x squared is equal to k. And that's it. That collection of curves is going to be orthogonal to the original collection of curves. And I invite you to discover this. Plug in, make k equal to 1 for both curves and plug that into Desmos and see what kind of curves you get. And you'll see that when the curves intersect, they intersect at a right angle if you've got the scale right. So that's it. I appreciate you watching, and I will see you in the next video.